Hey there, teachers. I just wanted to share a new resource. You can find a link in the description and learn about quadrays in the slides. And you can just study them on your own. You don't necessarily need to present these, but if you're one of my premier teachers in Nigeria or Somalia or somewhere, and you want to use these slides as they are, that's also totally okay. But learn enough in the background so that you've got the full story. That's why there's other slide decks and readings and so on, so you can get up to speed and offer this curriculum, which involves Python programming, which is partly why it's attractive, and a certain nomenclature, which is pretty easy to pick up. So there's teachers all over the world interested in these topics, and I don't always get to meet them or know them. If you're lurking in on this channel, you've seen how we cover this material in a lot of detail. And there's a lot of free software and so forth, so you're looking for a curriculum that will give you something of an edge because not everyone else is doing it. It's kind of a little bit of a niche. Is going to reinforce your knowledge of already mainstream topics such as XYZ coordinate system. Here we're using an alternative, but it plays nice with XYZ. So XYZ and IVM coordinates, they map the same Euclidean space. So I'd call it a high school topic. You can find it in Wikipedia, and you can find a lot of source code. I also take up the story of Waterman polyhedra, because he and I collaborated early on, but he wasn't really into the quadrays thing. For him, it was a trade-off. He either had unit radius balls and irrational XYZ coordinates in his packing, or he had rational coordinates or whole number coordinates, positive and negative, so integer coordinates and square root of 2 radius balls. But we don't have to make that trade-off when we're doing quadrays. All these IVM ball addresses are whole number positive, right? So there's a way to convert back and forth, though, between IVM and XYZ. So you do all your computations of the Watermans or whatever in quadray coordinates, and then when you go to render, your software does the conversion for you to XYZ, because of course there's no rendering software out there that will understand quadrays at this point. And that's fine. We do need a go back and forth kind of conversion. It's a one-to-one. There's one single canonical way to represent every point in Euclidean space with quadrays as well as with XYZ coordinates. So at the very end of this, there's a demo where I randomly create, let's go back to the main loop here. I start at 0 with 4, like you can think of them as turtles. And then each one gets to hop, say 1,000 times to its neighbors in 12 random directions. And you always get a whole number volume tetrahedron, even though it's completely random, because they're IVM balls, right? So that's where you'd pull up this demo here, go out of full screen mode. Typical at the end of a slide talk, right, is to have the demo and say, gee, I hope this works. But all you need to do is hit the green arrow, and it creates these random tetrahedrons, the methods I showed you, and gives you these whole number volumes off to the right. So this will all be in the repo. Have at it. Your students are waiting. They want to know what this stuff's all about. It's pretty hip these days, right? All right, talk to you later.